All right, so now we're looking at fall 2012, numbers one and number two as well. Let's go ahead and see how we would approach these. So what I'm actually going to do is I'm going to look at part A of number one and also look at number two simultaneously because I can, and also because they're very similar. We want to start with the likelihood, which is the product of the PDF. Replace x with xi, very important. Product of the PDF. We're normal 1 sigma squared, so okay. And don't forget the xi right there. Okay. Now, when we take this product, anything that's constant is going to be multiplied n times. And so if you have any doubts whatsoever about how products work, just go ahead and write out the terms over and over again. So it's that times that, x2 over theta, and then we have 1 over theta, e to the minus xn over theta. So if I have 1 over theta n times, that's 1 over theta to the n. And for the e, the exponents are additive, so it's 1 over theta summation of the xi's. Okay, over here, we have the constant to the nth power, 1 over 2 pi to the 1/2 to the nth, so that's 2 pi to the n over 2, sigma to the n, e to the minus 1/2, sigma squared, I'll just bring it out, summation of xi minus 1 squared. The summation occurs where the i's are observed, okay? We'll take the log likelihood. That's what we do. And in our case, log refers to the natural log in probability and stats. So that's going to be, all right, you got to know your laws of logs. That's n negative n, as I say, you got to know your laws. Negative n log theta minus 1 over theta summation of the xi's. Okay, over here, our log likelihood, or sigma squared, it's going to be the log of that. So it's going to be negative n over 2 log 2 pi minus n log sigma minus 1 over 2 sigma squared summation of the xi minus 1 quantity squared. Okay, next move is we need to take the derivative, partial with respect to theta. So that's going to be minus n over theta plus 1 over theta squared summation of the xi's. We'll set that equal to 0. When we set it equal to 0, that's when the thetas become theta hats. Okay. We don't have to explicitly do it there, but it's just something to keep in mind because that's an equation that's not true for all thetas. It's only true for theta hat. But at the end of the day, we can solve for theta hat MLE, and we'll get x bar. Okay, down here, we take the derivative. Okay, we're going to get 0 minus n over sigma, all right, minus 1 over sigma cubed, taking that derivative, summation of x of I minus 1 squared. And if we set that equal to 0, sigmas get their hats. And again, we don't necessarily have to explicitly always point that out. Okay. You didn't see that? That's a plus because of the negative exponent. When we take the derivative, move it over to the other side, and we get sigma squared hat is 1 over n summation of x of I minus 1 squared. Okay. So we have our MLEs for both of these questions. And the remainder of this video, I'm going to complete question number 2. We'll come back in another video to complete question number 1. All right, so for this one over here, the next thing we want to do is just verify or talk about the bias. Expect the value of sigma hat squared MLE is going to be 1 over n summation of expected value xi minus 1 squared. This is IID, so this is a constant that's multiplied or added n times. So it'll just be n times that constant. The n's will cancel. And this is just expected value of x sub I minus 1 quantity squared. We can use the chi-squared transformation. We can FOIL this out. We can do a number of things to identify the fact that this is equal to sigma squared. All right. I'll have you fill in the gaps. So therefore, it is unbiased.